Yeah, so today's the 19th. And I don't even know what to call this. So we're just going to call it super factoring. I don't really care. You can call it whatever you want. Um, this is our last push with cubes that spawn other things. And really, I don't think you're going to feel too much of a difference between today and yesterday. The main difference is that the problems are going to be disguised by, of course, the GCF. So at the front end of the problem, you won't see what I want you to see, right? I'm going to take a math problem and I'm going to write it. And then I'm going to sprinkle on a layer of GCF. And I just asked like my dog to help me with that. I'm like, hey, Sophie, what should the GCF be? And she's like, ruff, ruff, ruff. And I'm like, oh, 5x squared? Great. And then I just multiply everything by 5x squared. So that's how I apply a GCF. And then your job is to get it off of there and then attack the problem that's hidden beneath. That's how GCFs work. So anyways, let's do it. So we have 3x to the 20th minus 192x squared. At this point, you look at that problem and it means absolutely nothing. It's pure garbage. 3 is not a square, 3 is not a cube, 192 is nothing, right? What do we do? Yeah, I mean, that is it. That's your battle cry from now until the end of next week when we're done and we move into the regular like graphing polynomials and stuff. GCF, no GCF, no pass. So we're going to look at the numbers and use your calculator to assist you if you want. What can you pull out of first just the 3 and the 192? Yeah. If your gut tells you that there's a 3, your gut is telling you the truth. So let's pull out a 3. And what else can we pull? X squared. I'm going to take as many x's as they both have to offer. And then I'm going to reconstruct the problem. What's left over when I do that? So when I wrote this problem this morning, I wrote the white problem first again, and then I layered it on, right? You get that by now. So now I have to look at that and decide what it is. And it's got 2 right answers, but as we talked about yesterday, one of those answers is better than the other. And I'm not gonna go along for the ride if you elect to make 4 choices. So which one do we have to consider this as? It's a difference of squares. And again, if you're sitting there thinking it's also a difference of cubes, you're not wrong. You're just not trying hard enough to find the best answer. Those are squares. And you might say, but 18's not a square. Remember, with exponents, that's not about that. What does an exponent have to be for it to be square rootable? Just divide by 2. It just has to be even. And so x to the 18th is just as square rootable as like 4, right? So now we're going to observe it as a difference of squares, and we're going to break it down. So I'm going to keep my GCF out front as we embark on this little adventure, and I'm going to divvy that up into the typical difference of squares pattern. So x to the 9th go in the front. Good so far? You can. And I warned you about this a long time ago, that your ability to identify things, I'm not into vocabulary and stuff like that. I think that that's silly. But in this case, I'm into it just in the sense that I can't formulate a plan if I don't know who my opponent is. And I look at those 2 white things and say, I know who you both are. The first one is a sum of cubes, and the second one is a difference of cubes, right? So I'm going to take this first guy and say, what is A? It does. And just to pause there, remember, for anyone who doesn't quite get that, we're dividing our exponents by 3 to cube root that term, right? And what's B? It is. It is. And so the other side is really just the identical structure where A is x cubed and B is 2. It is. And honestly, you might find some today where your answer, in fact, not might. I know you're going to have one answer that has 6 sets of parentheses when you're done. What matters with this and what makes you good at this is understanding how to identify what you see. Remember, if you see something that can go both ways, difference of cubes, difference of squares, always pick difference of squares. And then just know how to recognize differences in sums of cubes. If exponents are divisible by 3, it's a cube, right? And then, of course, you have to know your cubes, your 1 and 8 and 27 and 64. You should know those when you see them and you can identify them. So yeah, you're going to find it very similar to what we've already been doing with the added layer on the front end of a GCF. And then a couple of the problems will have a couple extra added layers at the bottom. This one, we're one step from done. Can you already see why we know the next step is going to be the last step? Can you see it? Not necessarily what I was hoping you'd say there. What do you think? 2 is not a cube, right? And so if I really wanted to make this problem worse, I could have started with something bigger than 64, like 512, because 512, well, actually 512 wouldn't have even worked. I would have created something that when square rooted, like, I don't know what 27 squared is like. I don't know what it is. Does anyone know 27 squared? Never mind. It doesn't matter. The point is, if you ever want to write these and make them more fun, then you start with numbers that when rooted create numbers that are rootable again, and then those offspring are rootable again. So you can really have some fun with it and make it, my definition of fun and yours might not be the same. But anyways, yes, we are one step from done because of the 2s. Good job, Bryce. Thanks, buddy. 729 would have been lovely. Okay, thanks, Coop. Nice chat. So we have 3x squared, and now let's do a short set, long set for the purple ones. And then let's do a short set, long set for the green ones. And honestly, after this, I'm going to shut the recording. I'm not going to shut the recording off. I'm going to pause after this, and then I'm going to leave it open and let you start working on the assignment, and we'll go over questions as you have them. You should be fine. If everything is in place to this point, you should be fine. Like if you suck at cubes, you're not going to be fine. If you can't spot a difference of squares, you're not going to be fine. But if everything to this point is good, you'll feel no pain today. All right, let's go. What's my short set in the purple? Right, my long set. What? Minus 2x cubed, for goodness sake. And then my greens are going to be the same with just the sign staggering. So I'm going to have x cubed minus 2. And now the rest is plus, positive. You've already burnt your minus, so the rest is all positive. Yeah. And again, you see now how this had potential to go further, right? There's all sorts of creative things that I can do. But that one, not too much meat on the bone. Really, I think the moral of the story is make sure you get the GCFs. I believe every problem today has a GCF. Everyone. So if you don't get it, you're done. So pull the GCF step 1 and then look at who your opponent is. You're going to see a lot of cubes. I think the computer is going to give me all cubes today. Now, what those cubes spawn subsequently will change from one problem to the next. Good. All right, so I'm going to pause this. And again, when you guys have questions, I don't know if I published the page yet. So hold on just one sec. Serenity, would you read problem number 1 to me? I can't hear you over Swaggy B back there. Yeah. Okay. So if you're welcome to come along for the ride. If you're not coming along for the ride, just don't talk over me. We need to pull out 4x to the third. So this is problem number 1. If we pull out 4x to the third, we rebuild what's left. So hang on a second. So when we pull out 4x to the third, we're left with x to the 6th minus 1, right? So I know I already said this, but I'm going to say it again. And I'll say it again if I have to. I don't mind. This thing in parentheses, yes, it's a difference of cubes. And yes, you can say A equals this, but I'm telling you, if you stopped listening just now, just don't. Keep listening. It is a difference of squares. And when you have the choice between a difference of cubes and a difference of squares, please pick the squares. You're going to get more meat off the bone. Having said that, don't do A, B, short set, long set. Copy down your GCF and then factor it down just as a simple difference of squares. And when you do a difference of squares, things with exponents, you just take half of the exponents. No A, no B, no short, no long. You take half of x to the sixth, which is x to the third. And then the square root of 1 is 1. And you put it there and you put it there. This exposes more factorable stuff this way. And now I identify that the two things in parentheses, this one and this one, you've seen this before, those are now cubes. I don't have a choice on them because the 3 as the exponent is not divisible by 2. So I got to go down the QB road. Yes, Kinsley? You made it this far? Yeah. Good. So now that we've made it this far, now it's time for A, B. So on this first one, A is X and B is 1. And on the second one, I feel like we've done this exact situation probably before, but it's okay. A is X, not B. A is X and B is 1. Apologies for that. And then we're going to go GCF, short set, long set, short set, long set. So GCF is 4x to the third. Short set, purple short set is x plus 1. Purple long set. And then green short set is x minus 1. And then long set is all positives. So that's a completed problem 1. The moral of the story the last few days has become things that a week or two ago would have been their own math problems are now just little baby portions buried into bigger math problems, right? I'm also going to work out problem 2 if anyone is interested in that. What was the problem?
Problem 2 is x to the 7th minus 216x.
So again, I want to pull out a GCF in that. I'm really not talking quietly, FYI. So was that your way of telling people to zip it? Yeah, okay, I'll do it for you. Hey, zip it up. Can you hear now? So as I was saying a while ago, when I pull out the GCF, what I expose is one thing and one thing only. Unlike that last problem where you technically had a choice, were it not for your bossy math teacher, this time you have no choice. This one has to be perceived as a difference of cubes. And again, the reason for that is because the 6 goes both ways. The 6 says you can square root me or cube root me, do whatever you like. But the 216 says, sorry, I am not square rootable, so you don't have a choice. I am, however, on your list of cubes. Remember, 1, 8, 27, 64, 125, 216. He's next. And you're like, I know you. You're a cube. Therefore, the decision is made for us that this is going to be a short set, long set problem. Because of 216, the choice is made for us. So A is x squared. And B is 6, the cube root of 216. Got it? Now would be a great time to ask a question if you didn't know how I did that or why I did that. So this is going to be a pretty short problem. This is one there is not a lot of meat on the bone. I'm going to copy down my GCF, and then I'm going to build a short set and a long set, and I will at that point be done. And again, Sutter answered this earlier. Why do I know that there's not going to be a step after this? Because x squared minus 6, the short set, is not a difference of squares. It's a wannabe difference of squares. It's like, I got the x squared and I got the minus. I'm ready. Oh, never mind. 6 is dead. And even if 6 were a cube, I wouldn't care because the 2 says I can only be a square. So if that guy over there, 6, is not a square, then this is the end of the road. And then the long set is x to the 4th plus a times b, 6x squared, plus b squared, 36. So as I said earlier, not all problems are very exciting. Sometimes you GCF it, do a step, and you're done. And that'll happen on a handful of problems here. Got it? All right, I'm gonna pause again. I'll leave that on the recording, but if you guys have more questions, let me know. Number three. Number three is like 8. I'm gonna make this up as I go. 8 x to the 8th
minus x
There's no y there.
and y to the 6th.
So your job is to be able to look at this and say, what do they have in common? They do not have a number in common. So 8 is flying solo here, but they do both have x squared to give. You cannot pull out a y if they both don't have it. So I'm going to pull out every little ounce that I can. I'm going to pull out x to the tooth, and then I'm going to reconstruct the problem. What is left over of the first term?
It'd be 8x to the 6th.
8x to the 6th minus. Good. Now, the first thing I noticed as I walk around is a lot of people have questions on this because you should follow along right now because they gadoinked it and put a 4 here. I don't fail to understand why you would want to do that because logically 8 divided by 2 is 4. But remember, when you pull a GCF, you're actually subtracting out an amount of things. And 8 take away 2 is 6. Are we good to here? And these are the questions that I need you to be able to answer and not just wait for someone else to answer. If you're sitting in this room and you're like, I don't know the answer, but I don't want to feel stupid, get over it. What is that? What is it? What is the white thing?
A difference of squares.
It is not a difference of squares because 8 says, I don't know what you're smoking, but I'm not a square. You can't square root me. Bless you. If I'm not a square, then I am not a part of a difference of squares. It is, however, a difference of cubes. And there are 3 reasons for that. Reason number 1 is because 8, the number, can be cube rooted to make 2. 1 down. The next reason it's still in the running is because 6 can be divided by 3. So it's cube rootable. And the final reason is because this 6 can also be divided by 3. Therefore, all the components of this problem say, we're cubes. We're cubes. There's a minus in between us. We're called a difference of cubes collectively. And now it's time for us to find A and to find B and to long set, short set it. Austin, does that make any sense? So now it's time to do our thing. What is A? 2x squared. 2x to whatever power I get when I divide the old one by 3. If you're square rooting, you divide the power by 2. You're cube rooting, you divide by 3. So A is 2y to the tooth. Excuse me, 2x to the tooth. And what is B? Yes. And now we've got all of the components that we need. We've got our GCF, we've got our plan of attack. We know that they're cubes. We know to do short set, long set, and this is going to happen and be done. So we have x squared, that's the GCF. I'm trying to always write my GCF red, so you can always remember where did he, oh yeah, that's the GCF. That thing just sticks around like a bad cold. Remember, once you pull it, it's just there. Stays with you.
Your short set.
My short set will be what?
2x squared minus y squared.
Yeah. And if by chance you were to look at that and say, my God, I don't know how he got that, you better get in here and get help. That's just A minus B, God's sake.
And then your long set.
And my long set is going to start with A squared, which is, yes, 4x to the 4th.
Plus.
And again, for those of you who are wondering where I got that, that is A squared. All it is. This is not our first time going through this. 2 squared is 4. X squared squared is x to the 4 plus.
And y to the 2nd.
Yeah, that's a mashup. And that was something we addressed yesterday was the mashup in the middle. Remember, there's no real math going on in the middle generally. It's just a point them together and stick what you got. AB. And then at the back goes what?
Y to the 4th.
B squared. And that is done.
It's supposed to be an R-I-U.
No, I spelled done my own way.
All right. I got you.
I'm inventing my own English. Yeah, like x to the tooth, right? You can't stop me.
How would you spell it?
I don't know. That's a good question. That's how you do problem 3. And again, what prevented us from going further? What one number on the board prevented us from going further? Right there. He's the deal breaker. He's the brake pumper. He says, no more. I'm not a square. I'm part of something that badly wants to be a difference of squares, but sorry, I'm mooking up the whole program. Done. Right? If he were a 4 or a 1 or a 9 or a 16 or a whatever, then we could go another step. Right?
It didn't exist.
Right.